Hello again, guys. How are you? We have today our next video. It's going to be IPSec VPNs. Particularly, we're going to discuss point-to-point tunnels. Here in Firefly, we are changing the way we learn, evaluate, and adopt technology. I'm Agustin Siciliani. Hope you find this helpful. Okay, this is our agenda, our topics for this video. We're gonna first of all discuss a little bit where to start in terms of IPSec. IPSec is actually a suite of different protocols working together. There's a lot of information, a lot of RFCs, a lot of RFCs that are basically making other RFCs become obsolete. So it's a bit difficult, to start reading. So I'm gonna grab some of the the main RFCs for you and explain the main topics there. Then we're going to go deeper into the IKE, which is a negotiation and management protocol for IPSec. Then we're going to go through IPSec itself, which is actually the transform sets, which is a protocol actually doing the magic and sending that traffic securely for us. Basically, we're going to touch base real quick on the NAT traversal considerations when you're having your IPSec tunnels going through NAT devices. And finally, we're going to go our lab and see IPSec in action. By the way, just a brief introduction. This is going to be by the end, so stay until the end. This is the lab that we're going to discuss. Real quick, we're going to use IPv6 as the overlay protocol in a IPv4 IPSec tunnel. So stay tuned. That's what we're going to see when we reach the lab section. Okay, so where to start? As I was saying, IPSec is actually a suite of different protocols that work all together, to secure our IP traffic. And here, again, there are like dozens of RFCs discussing IPSec, IKE, ESP, AH, so the different protocols of IPSec, and of course, all the different evolution that all those RFCs have taken across the years. And as there's so many, the IETF actually created one RFC, which is a 6071, which is actually an IPSec and IKE document roadmap. So it basically helps you navigate all the different RFCs that are around to discuss IPSec. Then we have our RFC 4301, which is the actual architecture of IPSec. So let's say the framework of IPSec, how it works, the different components. Then we have RFC 7296, which is for IKE version 2. We're going to see some details there. Then we have RFC 4302, which is specifically for IPSec authentication header. That's one of the flavors, let's say, of IPSec. And last but not least, RFC 4303, which is IP ESP or encapsulating security payload, which is the most commonly used IPSec flavor, when you're doing IPSec tunnels. By the way, as I was saying, there are a lot of more RFCs around there. We're going to focus on these RFCs shown here. So basically, the next slides and all the information that I'm going to give you are based on these slides. And particularly, we're going to focus on IKE version 2 and ESP, which are the most commonly used flavors nowadays. And particularly, we're going to focus on IPSec version 3, which is a newer version of IPSec, as well as IKE version 2, because we have IKE version 1, and now the newer version is IKE version 2. So that's why they are highlighted here. Okay, let's move forward. So first of all, just from the basics, why we use IP security protocols, why we need IPSec, basically to have confidentiality, data integrity, access control, and source authentication. So basically, we need to send traffic across two sites or across two hosts, and we want that information to be sent securely, that nobody can see what I'm sending, that this communication is private and encrypted. That means if somebody else is able to grab some of those packets that are flowing through that tunnel, they cannot actually see the information that I'm sharing, with somebody else. So for confidentiality, we're going to do the payload encryption. That's why we encrypt the packets. For integrity, we're going to use hashes, right? So we're going to create signatures that basically tell us that those packets are really coming from the host that I'm actually think they're coming from. And we're going to use for access control, source authentication, and different things, these key exchanges that we're going to see how IKE manages all that, to create securely the keys and use them, to encrypt and authenticate and authorize all that traffic. By the way, if you're going to check this from the security body side, what are reply attacks, I really encourage you to take a look there. There's a nice explanation of what they are, and that's another reason of why we would need IPSec, to protect our traffic, because we are subject to these kind of attacks. Okay, so a little bit of the IPSec roadmap and architecture. As we were saying, we're going to discuss specifically IPSec version 3 and IKE version 2, which are the newer versions of both protocols. But you may see that IKE version 1 is still in use in some implementations, and maybe IPSec version 2 as well. But we're going to try to focus on the newer versions, at least from the time that we are recording this video. So here you see the architecture is one of the drawing taken from one of the RFCs, from the architecture RFC. So you can see that basically the two main protocols of IPSec are going to be ESP protocol and authentication header protocol. And these two protocols have different capabilities. In the case of authentication header protocol, it can only provide integration protection for us. Whereas in the case of ESP, it can not only provide integration protection for us, but it can also, with the combined mode, it can also provide encryption for us. So that means that when we speak about integrity, what we want is to make sure that the traffic is coming from who it says it's sending the information for us, and there's nobody else trying to send that information, making us think that it's somebody else. But in the case of ESP, not only helps us to validate that, but also it's going to help us encrypt that traffic. So if anybody is watching that traffic, maybe with a sniffer, Wireshark, or any kind of tool, seeing those packets, they will not be able to understand what we are sending. And finally, our IKE protocol, which is the one that's going to help us manage all those keys, all those exchanges. So it's going to prepare everything so IPSec can start encrypting securely our traffic. Then we're going to see also the IPSec modes. We're going to have two main modes in IPSec. One is going to be the IPSec tunnel mode. Then the other one is going to be the IPSec transport mode. The most commonly used is the IPSec tunnel mode, and it's the one that we're going to focus right now. But you have to know that the transport mode is there. So when we say transport, that means that, as it says here, the IP addresses of the source and destination of the IPSec traffic are kept as the original source and destination. Whereas in the case of the tunnel endpoints, or the tunnel mode, we're going to have two security endpoints, which are the ones creating that tunnel. But the real source and destination of the traffic are going to be somebody else in different networks. In this case, you see the example. We have here protected subnet, which is, let's say, the source of that traffic, or source or destination, depending on the flow. Then you have in the middle the secure part of the communication, which is between the tunnel endpoints, and then here the other protected subnet. So the source and destination are in these two protected subnets, but in the path of that communication, we're going to have our tunnel. So during the tunnel, during the the communication of the tunnel, we're going to have different source and destination of the traffic. Source and destination within the tunnel are going to be the tunnel endpoints, but when we go out the tunnels, the real source and destination IP addresses are going to be found. And finally, another that is commonly used is the remote access. In this case, it could be one device connected to the internet that wants to get into the company, for instance, company network. In that case, that's kind of the example of remote access, and that's when a protected endpoint creates a tunnel towards a security device of our company, and we let that traffic in only to access resources of our company securely, of course.